Go ahead and get your packets out here, and well, a lot of work time today. We got some people stuff to do the quiz from yesterday, so we won't be going over that yet. But the take homes I do have, if you want to take a look at those later. Probably talk about the pipe problem here in a minute. Any of them, I don't care, whatever. We'll take some questions here in a minute. But I did want to talk about the one tomorrow, the test tomorrow, and the kind of the scale, and we've talked about that a little bit, how that works. And maybe I can talk about the one on Monday as well. But so basically the one tomorrow is going to have 17 multiple choice questions. I mean, and this isn't necessarily important information for you. Just do the best you can, right? There's no penalty for guessing on the multiple choice. You want to make sure and answer them all. If you have to guess, you should guess, but don't leave them blank. Free response is just like a normal quiz where you show your work and you get partial credit and that kind of stuff, right? So just like the packets have been. So tomorrow what we'll do is all no calculator stuff. So the multiple choice and the free response together. Now in a normal full AP test, there's 28 multiple choice no calculator questions. And only 2 no calculator anymore. It used to be 3 and 3 on the free response. So this is kind of a partial, just like our packets have been. So we're going to do 17 multiple choice questions. So they're each worth 1 point. They're either right or wrong. And then the 3 free response questions have multiple parts to them, just like the ones we've had. And then you get certain points. So I'm not sure how much each one's worth, but together they're worth 19. So you can see it's about half and half, right? So time-wise, you want to make sure. I don't think time will be any more of an issue than it is on most quizzes. I think at the end of the year when we do our final, the 28 multiple choice questions where you only get 56 minutes, I think that's some time pressure, or 55 minutes. But I think this one, because basically the way I'm doing the time is it's essentially 2 minutes per question on the multiple choice no calculator. So that'd be 34 minutes. And then it's supposed to be 15 minutes for each free response question, which is quite a bit of time actually. And these are only parts of some of the free response questions. So I'm going to still give you 15 minutes. So that's 45 plus 34, so it's going to be like 79 minutes, which is most of the block, right? So I don't think the time pressure is any different than it is on a normal quiz. But just so you know, there's as many points, there's even a few more points on just those free response questions as there is on the multiple choice, right? So make sure you get to spend time there, but again, I don't think it's a huge deal. So here's a scale. So 24 out of 36 is the cutoff for an A. So that's what, a 67%, 66, whatever, roughly what we talked about, 65 for an A, it's in that ballpark. Okay, 19 out of 36 is a cutoff for a B. So that'd be a cutoff for an A is a 90, cutoff for a B is an 80. So what's that, a little over 50% is a cutoff for a B. Okay, 15 out of 36 is the cutoff for a C. Okay, so that'd be whatever, I don't know, 40%, somewhere in there. Okay, and then 9 out of 36 is the cutoff for passing. So what's that, 25%? Okay, so, well, yeah, I don't know if you should be worried about the difficulty of the quiz. I think I've talked to you already about the difficulty. You've done the packets, right? I mean, it's just like the packet. Okay, so you already should have a sense of the difficulty level. So, if you feel like you're getting half of them, that's almost a B, right? So just understand, when you walk out of here, you might be going, man, that was really hard. But, right, I mean, that's the way the AP test is. That's what it feels like. So that's the scale, okay, on that one. Now, the calculator one, the one we take on Monday, that one is going to have 10 multiple choice questions, okay? Because on the actual AP test, they give you 17 multiple choice questions in 50 minutes. That's about 3 minutes per question, because I think they figure if you're using your calculator, it takes a little longer to type stuff in, whatever. Okay? And then there are 3 free response questions again for a total of 21 points. Okay? So this one has a total of 31 points, but it's weighted more heavily in the free response, right? So you want to make sure and spend, a decent amount of time in there. But again, I'll give you 30 minutes here plus 45, so it's like 75 minutes. So it still should be plenty of time. I don't think the time pressure, again, will be huge on this one especially. I think what typically happens is people hand it in early because they've done about as good as they can do. Otherwise they're just sitting there staring at the paper. So probably get done earlier with that one. Here's a scale on this one. 21 out of 31 is the cutoff for an A, which again is right around that 2/3 mark. 16 out of 31 is a cutoff for a B, which again is just right around half. 12 out of 31 is a cutoff for a C, and 6 out of 31 is the cutoff for pass. Okay. 6 points. So if you can get 6, but there's only 10, but that's 6 points, right? So 10 multiple choice. So if you get half of them, you only need 1 more point in the free response to pass, right? So if you look at kind of the quizzes we've had recently, right? This should be a, what do we call it? Grade enhancement opportunity. How about that? Okay? Don't think of it as a midterm. Think of it as a grade enhancement opportunity.
This is a great killer.
Shouldn't be. All right. Now, just to give you a sense, last year, now it varies a little bit because I've got several different versions, so I'm not sure, which version. It wasn't this version last year. I guess I can show you that. I could talk about the last time I gave this version. The class average was 49.8%. That's the raw average before the scale. So right at 50%, which would be just at a low B, right? Which is probably a little higher than a lot of our average. I think the last quiz we took, well, the one yesterday, I think the average was low C probably. Yeah, it might have been higher. I didn't really look, to be honest with you. Another time it was 54%. Right? So the highest grade, whoops, that's the one. It's been as low as 42% average-wise, but in that ballpark. Someone last year got 34 out of 36, the one we're doing tomorrow, 36 points. Okay. I don't remember. 33 out of 36 another year. One year it was 28 out of 36 was the highest. So that's the one to shoot for, 34. We need somebody to beat 34 out of 36. Okay? All right. So it's doable, right? It's doable.
So if someone does that well, does that change?
Nope. That is the cutoff right there. Yeah, that's what I'm saying. You guys know already that's curve. So if everybody gets above 24 out of 36, you all get A's. Right? Everybody can get A's. That's fine. Everybody can get F's. That's not going to happen. Okay, I'll be right back. We're going to go over some of the packed ones here in a minute.
Yeah. Yep, that's why I was late. They're what?
So this is cushion the blow.
Oh, I don't think it will. Right.
Okay. All right, page 30. This is exam 2, number 15. Okay, now, if you've already seen this one or you've asked me about it, you just start working here, that's perfectly fine. But I thought we could just go over a couple things, and I did want to talk about the pipe problem here before I let you get to work too. But all right, so on this one, dy dx just means y prime, so it's a implicit differentiation. So the derivative of the outside would be secant squared. We leave the inside alone. Times the derivative of the inside, and that's going to need parentheses because it's going to be a plus in there. So the derivative of the inside, the derivative of x is 1. The derivative of y is y prime. And then equals the derivative of the x on the other side is just 1. So we need to get this y prime by itself. So ideas. Divide by secant squared. So you have 1 plus y prime equals 1 over, now what's 1 over secant squared? Cosine squared. Okay, so I'm going to write it like that right away. So 1 divided by secant squared is the same as 1 over, or excuse me, is the same as cosine squared. Okay, and then we subtract the 1. So we got cosine squared x plus y minus 1, which is right there. Okay? Anything else? 16? Here we go again. X.
Yeah.
Just do it, huh?
Just keep it.
I mean, I could use a practice, but I don't know if I need it that bad. The derivative of f of g of x. I got a couple of choices here. One choice would be to just put g into the f function, right? Because that's what f of g of x is, right? It's a g function put into the f function. So we could take ln x and put it into there. Is that what a lot of you would think to do on that one? I mean, it seems like that's what a lot of people tend to do on this one. So let's do that. So that'd be e to the 2, ln x, right? Okay. And then now, at that point, now we want to do the derivative of it, right? So we could do the derivative of it right now. So there's a lot of different options on this one. We could do the derivative right now, it'd be fine. This is e to the u, right? So the derivative of e to the u is e to the u times the derivative of u prime, right? What's the derivative of 2 ln x? Well, it'd be 2 times 1 over x, which would be 2 over x, right? So that would be the derivative. Now plug in an e, right? It says that x equals e. So you put in an e, what's ln e? 1, right? That's one of those things you got to know, right? I mean, that's good. I guarantee it's going to be on the no calculator one, right? ln e, ln1 is 0. All the trig things, all those trig values you're supposed to know, all that stuff, that's in the no calculator part, right? So ln e is 1, so this would be e to the second times 2 over e. And then that e would cancel one of those e's, and we would have 2e. So that's one way to do it. At the beginning, not until you've done the derivative. Yeah, I could have plugged d in So I don't know, I couldn't have plugged the E in here, right? I don't know what you mean by the beginning. Here? Because I haven't done the derivative
The
yet.
second.
This one. Yeah, that's what I just did, yeah. So I put E right here, so that's 1. Yeah, so that's what I did. Okay? Now the other thing we could have done is we could have rewrote this. What can you do with this power outside, or this 2 outside of a log? You remember that rule with powers? You could bring that 2 in there and make that x squared. So this would be e to the ln x squared. Now what advantage is that? Well, what's e to the ln x squared? Okay, yeah, forget this one.
X squared.
It's just x squared, right? That's x squared. Square root of x squared is x, right? They undo each other. E and ln undo each other. So it's just x squared. So now I haven't done the derivative yet. That's just the function. So this function is actually just x squared. So what's the derivative of x squared? 2x. Now put it in e. 2e, right? So you could have done that. The other thing you could have done, I'm running out of colors, let's do black. You could have done the derivative of f of g of x. You could have done f prime g of x times g prime. Like that. Okay? So now that's your derivative. Now you could have plugged these things in. So now you could have plugged your ln x in here. So you could have done f prime ln x. Okay? And then g prime, that's just 1 over x. And then you could have said, well, what's f prime? Well, that's this. F prime would be e to the 2x times 2. So that's f prime with an ln plugged in. So that's 2e to the 2 ln x. Right? I just plug an ln x in there for that x times 1 over x. Now you look at that, that's the same thing I had right here. Right? Except, yeah, no, same thing. Because here this 2 would be that 2, e to the 2 ln. I got the same thing. So I could plug e in there. So that'd been the other thing you could have done. But this is really the slickest way. Do that, turn it into that, do the derivative. But, yeah, saves you a little time maybe if you saw it, but if you didn't see it, that's a problem. Okay, Kat, let's go. Let's go do this. All you need is a pencil. Okay, think of another one you might need. I want to do the pipe one here in a minute, too, also.
Give me another piece.
Okay. What else? What else? Anything? 19. Is that the next one? That better not be the next one. Oh, good. You skipped 18. All right. Very good. All right. The derivative of that. This is just the old, like, gateway test. I mean, this is just, yeah, there's nothing fancy about this, all right? It's just a plain old derivative. Now, you've got to get it into a form that would be helpful. So this would be x to the 1/2, and then this would be x to the first times x to the 1/3, which is x to the 4/3, and it's on the bottom, so it's x to the negative 4/3, right? So if you can't do that, probably not going to do the problem, right? I mean, honestly, you've got to get it, because we don't have it, there's no other rule. We have no other rule for how to handle that. I suppose you could make all that to the -1 and do it as a prime, but that'd just be an ugly, ugly mess. So you really got to get to here. And then once you do that, then it's just your power rule. So you subtract, let's see, you bring that down, that'd be 4/3 x to the, what happens if you take negative 4/3 and subtract 1? Negative 7/3, right? And luckily they kind of keep it in that. Where's it at? Right here. B. Right? Now they could have made it a little harder if they'd have then taken it back into like cube root and square root kind of
So mean.
you know, that would be a little mean, yeah. They can be a little mean, that might be a lot mean. But, so it's nice that they left it that way, but, okay? Oh, yeah, this, inverse function, this is good. Now, again, say this, said it multiple times, 65% is an A, right? You get an A, there can be some where you're just going to, possibly, now hopefully we've tried to limit that number, but there's going to be one at a time. Inverse function could be one of those situations. Inverse function ones are ones that we have talked about a little bit, but they don't show up very often, you know, so as a, you know, my decision is always how much time do we spend on certain things, because we don't have time to do it all and spend a lot of time on it all, right? We can talk about it here and there and every once in a while, but then those are hard to remember, especially if you don't do them a lot. So inverse functions. Let's do this one. Let me talk a little more about inverse functions in case it comes up and you can maybe remember enough of it. But basically this just says what conditions assure that G has an inverse function. So if that doesn't mean anything to you, how do I know if a function is an inverse? Then the next thing I would do would be to just look at what this stuff tells you. So G prime less than 1. So what do you think of when you read that? What are some things that come to mind? Just G prime less than 1. What's that mean? Slope. So what's it mean if the slope's less than 1? It could be negative for sure, right? So the graph could be going down, but it might not be going down. It could be going up, right? But not very steeply, right? So it's not going up very steep, can't be more than 1, and it might be going down. Okay, it could be doing anything. I'm not sure what that's got to do with anything, but we'll see. What about this one? Oh, now that it means it's always increasing, right? G prime greater than 1 means it's positive, it's always increasing. So the G graph would be doing that. Okay, G double prime positive. Concave up, so that's always concave up, okay? G double prime negative, concave down, and continuous, we know is always connected, no breaks or gaps or anything. Okay, so now what's that got to do with an inverse function? Well, maybe it doesn't help at all. But which of the following conditions assures that G has an inverse function? Here's the thing. If I have this parabola right here, what's its inverse look like? Sideways parabola. Is that a function? Fails the vertical line test. So, what has to happen on a function if its inverse is going to be a function? It's gotta pass the horizontal line test. That's probably something you talked about in Algebra 2, Advanced Math at some point, probably hardly at all, one day, whatever, didn't make a big deal about it. But there's something called the horizontal line test. A function has to pass the horizontal line test, means it can't cut through, a horizontal line can't cut through more than once. If it does, its inverse will fail the vertical line test. Okay? So, we can eliminate this one because here's concave up. Does it have an inverse? No. Right? Its inverse would be a relation, but it wouldn't be a function. So it doesn't have an inverse function. So anything, it's got to be something like this situation, right? It's got to always be going up or always be going down. The term actually is monotonic. Monotonic means always increasing or always decreasing. That's what has to happen for a function to have an inverse. Okay? So, that's why the choice is B. Because the slope less than 1 means it could be going up a little bit, as long as it's less than 1, and it could be going down. Well, that's going to fail the horizontal line test. Concave up, concave down is going to fail. Continuous doesn't have anything to do with it. All those are continuous. So this is the one. So I don't know what more to tell you other than that's what you can know about inverse functions. Okay? All right? Now, another thing, this is what more typically will come up about inverse functions, has to do with slope. And this we did cover. This we did talk about. And we talked about that too. I'm not sure we used the term horizontal line test, but we talked about the sine curve. And we talked about if you're going to do the inverse of the sine curve, the problem is there's a whole bunch of values. There's a whole bunch of angles that have a sine of 1. But if you're going to do the inverse, then that means you're plugging in a 1, and then you're going to get out all these other angles. Well, you can't do that. It's not a function. You got to get out only one value when you're plugging something. So we said we restrict the sine function from negative pi halves to pi halves. And we talked about this when we were doing inverse function. We were doing arc sine or cosine. Like I said, probably one day we did it. Well, why do we restrict it from there to there? Because it's 1 to 1. It will pass the horizontal line test that way. Then the inverse will be a function. Okay, so we talked about restricting domain, stuff like that. Okay, so we have talked about it. The other thing about inverse was this. If I take the parabola and just take that part of it, okay, now its inverse would be the sideways parabola, like this. Now here's what we talked about. If I take this point, which is 3, 9, and I take this point out here, which would be 9, 3, those are like the mirror images of each other, right? Interchange the x and the y, remember that? All right. Now what's going to happen? Their slopes are going to be reciprocals of each other. Not negative reciprocals, but reciprocals. That's positive, that's positive. But if this slope here is 1/6, excuse me, if the slope here is 6, because what would be the derivative of x squared would be 2x. So let's call this function f, let's call this function g. So f prime of 3 would equal 6, okay? The slope there is 6. The slope here is 1/6. Looks reasonable. But how would we write that? That would be g prime of 9 would be 1/6. So what happens with inverse functions is their slopes are reciprocals, but they don't happen at the same point. They happen at the mirror image point, at the interchange point. So on the f function, the slope that we're talking about or interested in happens at 3. On the g graph, it's inverse. The slope we're talking about that's the reciprocal happens at what was the y value of the f graph. It's now the x value of the g graph, right? So it's not like f prime of 3 and g prime of 3 are reciprocals. It's f prime of 3 and g prime of 9 that are reciprocals, okay? Has anybody remembered in any of the packets a problem that had something to do with inverse? Maybe it hasn't been in it. Maybe I'd be surprised, but maybe it hasn't been. It's possible. Because it's one of those, like I said, it's definitely one of those that if you miss it, you still can get an A, right? I mean, they're potentially gonna be some of those, okay? All right, so anyway, that information can help you do one of those problems. And it can ask it in a variety of ways, but if it has something to do with inverse and derivatives, that's kind of the information you want to remember for that, okay? Well, if somebody notices one, we can sure do it. Okay, let's talk about the pipe problem, because I do want to give you some work time here. Oh, good luck. That's for fun. Let's talk about the pipe problem really quick. There was a number of people who missed that. It lost 3 points. It was worth 5 points overall. So if you had 25 out of 28, maybe that's the one you missed, right? Because there was a pretty significant number, which was interesting because I don't remember seeing that answer before when people have done that problem. So, you know, it's a take-home. I told you to work together, so that's fine. So I don't know if 12 different people all did it wrong or if one person did it wrong and happened to be working with those 12, you know what I mean, those 12 other people. But here was the answer that I saw is 12 root 2, 16.971, something like that, okay? And here's what happened. Here's what happened for the people that did that. We talked about setting it up, and it was going to hit right there. And what those people did is they split this into 2 parts, and so they had P equals A plus B, like this. Now, some people had that on their paper, some people didn't. And then typically what was happening, you had a 4 here, you had a theta here. Let's see, did you use theta? No, you didn't use theta. What did we do? Was there an X? Was there an X there? This was 8. Was this Y? I think that's what it was. So on this triangle, you'd have h squared plus y squared. Does that look familiar? Equals a squared. And x squared plus 4 squared equals b squared. So a would equal square root of 64 plus y squared like this. And b would equal square root of x squared plus 16. And that wasn't it? Was that it?
It's similar.
Okay? And I think that's, yeah, I'm looking at one right here. Yeah, I think that's what it was. And I think what went wrong here is you did these two separately then. What happened was people did the max of this, like did the derivative of this, set it equal to 0, did the derivative of this, and set it equal to, you see what I'm saying? And so they found like the max of this piece and the max of this piece. The problem is that by doing that separately, what you're finding is might have been a pipe that went from here. Remember, because the pipe, this is a set of all pipe that hits these 3 points, right? But by doing those two pieces separately, what you found was a link that would go here and then maybe another link that would go there. Like it would bend there. There'd be a bit, you know what I mean? But you can't do those separately. What you needed to do, what you're doing is you want to do the max of the pipe length, right? So what you needed to do was take this and put those there and there. And then do the derivative of that. Now, you might look at that and say, well, yeah, but that's what we did. We got A prime here, we got B prime. But look what you did. You set A prime equal to 0 and you set B prime equal to 0 separately. If you set this, if you set A prime plus B prime equal to 0, does that mean one of those has to be 0? You see what I mean? See the difference? So what was happening is you were setting this equal to 0, getting a candidate, setting this equal to 0, getting a candidate, and then using that. And now it came up actually pretty close. I think the actual answer is 16.648, I think is the answer. But that's the problem. By doing those two individually, it'd be like doing A prime plus B prime equals 0, but that would not be where each one of those equals 0. It'd be something different. So that was the dilemma on that one. So anyway, if you'd have done this and then set this one equation, so it would have been this plus this equals 0 and solve that. Now, problem is you got two different variables here, so you had to relate those somehow. And I can't remember if anybody did that either. I don't think you did. And that's probably why you set these equal to 0 separately, because you had two equations, maybe you weren't sure what to do. But we can relate these because it does, let me see, let me think about this. It would be similar triangles. This would be theta, this would be theta. So you could have, let's see, 4, would that be right? 4 over x would equal, 4 over x would equal y over 8. So xy would equal 32. So y would equal 32 over x. So then this could get put in there. So that's how you would get it down to one variable. There was a group I know that did it that way, that got it. So you'd have this plus this, so that plus that, but you'd have to actually, I'm sorry, you'd have to substitute it here, and then you would do your derivative from there. Okay, so you had to get that substituted. And you might have done that. Maybe some of you did that. But again, if you did those separately, that was going to be bad. That wasn't going to work. Okay? And there were multiple other ways. I think I've worked at 4 different ways with using trig and using some other stuff too. And it all comes up to that. Okay? But otherwise, it was pretty good. I mean, a lot of people, there were a number of people who got 28 out of 28, 27 out of 20, just missed one or so. And then there were a lot that got 25 out of 28, just missing this one here. So, okay? All right. I tell you what, let's just stop there. I've got that other packet if you want that, if you haven't taken one. And let's just work. Let's just have some work time here. One answer book, so share, please. And let me help you, right? If you got some questions on some of them, work together here. But if I can help your group out a little bit, work through some. If I think of some things, I'll try to think of some things as we go through the day here. If I got any other advice or hints or anything for tomorrow. But really, it's just be practicing as much as you possibly can. Okay? might be good to, if you're working on, let me say a couple other things. On these last two packets, the free response, actually, it says you can use your calculator for any of them, because a long time ago, which is kind of where these packets come from, you could use your calculator or anything, but that was before they started splitting it out, doing calculator, no calculator. So I would suggest you try to do the free response as much as you can without a calculator, okay? And then if you just find you just really need one, want to use it, then go ahead, that's fine. But you might want to focus on the no calculator ones a little bit. So like if you haven't taken this new packet, or if you haven't moved into the last packet, might be a good day to go through the no calculator part of this packet, right? And that way for Monday, you're leaving yourself the calculator ones to practice. Because that's what we're going to do tomorrow is the no calculator. Okay? All right. Go ahead and go to work. Yes.
On this one, so after you put y in here, you put x of 2.
To get the y value.
Yeah, so it's 41. I don't get what I do after that. It says in
You need a
equation-
point equation tangent line.
Yeah.
Always when we do equation tangent line, it's the equation tangent line y equals m times x minus the x point plus the y. So they gave you the x point was 2. You just found the y point was 41. So what do you need?
I need this.
You get some.
The derivative.
Yeah.
Oh, so that would be.
It's the only thing we've learned all year
Okay,
long.
so then I did that.
And you
I
plugged
get
in
1/2.
You plugged in a 2, correct? Why'd you set it equal to 0? We don't care about where the derivative is 0,
Okay.
right? Derivative is 0 like here.
So just
What
do the
we care
derivative.
about is what's the slope when x is 2. That's what we care
Okay.
about.
Got it.
We have a few more.
Come with 2 packets in here.
Number 5 says 2. So if I'm the derivative of y, then you had to find x's before that.
And that looks like that multiple choice one we just did. Oh, it's different. Never mind. Okay, so what now? You found what?
Find the derivative of y.
Okay, which is that?
Yep.
Okay,
So then find. I'm confused about being
where the tangent line is vertical, which would be where the derivative is undefined, so that'd be where the bottom is 0, so you gotta solve that, yeah. Well, what's secant squared? It's 1 over cosine squared.
I'm looking at this.
1 over cosine squared, so then multiply cosine squared. If you don't feel like dealing with secant,
There is no
turn it to cosine, so it's 1 over cosine squared, so multiply that over there. So you have cosine squared equals 1. So that'd be where cosine is plus or minus 1. So where's cosine plus or minus 1? 0. That's where it's 1. Pi, it's negative 1. 2 pi. Now this says x, so you're finding y. Now it turns out that x and y are going to be the same here. But it's from negative 2 pi to 2 pi. So 0, pi, 2 pi, and then go back the other way, negative pi, negative 2 pi. Those are all right. But it says less than, so you wouldn't. Those are your x. Those are your y values, and then you can plug those back in and get the x values.
I was
this
looking
one.
at it.
This definition of derivative.
Right. It's a derivative of what? It's a definite derivative, so it's a derivative of what function? Yeah.
So that's
So it's b.
yeah.
Yeah, it's just derivative cosine.